morning. It must have been a really great party last night. It's always the risk whenever you have the second keynote. Thank you for having me back. This is my fourth Scala I/O, and as always, this is one of my favorites. I love community conferences and not the big shows with corporations, and Scala I/O has always been that kind of conference for me, so I'm really glad to be back. I'm sorry I wasn't here yesterday. I wanted to spend Halloween with my children because they're only going to be young for so long, and it was a lot of fun, and that meant that I couldn't fly out until the 1st of November. So thank you for having me. This talk is about beyond eventual consistency, and there are several databases that are coming out these days that are changing the way we think about distributed data. And because I personally don't like writing consensus protocols and really hard algorithms around trying to make sure that my data is consistent across a whole bunch of nodes, I started looking into them because I've got hard problems to solve. So first of all, I'm Jamie Allen. I work at Starbucks. I used to work at Lightbend and TypeSafe. I'm really excited to announce that for the first time in 5 years, I'm in production. Woo! Thank you. It was really exciting because when you work at a company like TypeSafe and Lightbend, you aren't putting code into production. You are for other people, right? Because you're making libraries that other people use in production. But you yourself don't have to operationalize something. You yourself very rarely get the beeper call in the middle of the night. Did I just say beeper? Yeah, so I'm old. But what we're building at Starbucks is the rewards platform. How many people here might be a member of the rewards platform where you get points and you can redeem them whenever you earn enough of them? We're rebuilding that because our experience is different all around the world, and that's bad. You come to the United States and you don't have the same experience that you do here. Or even in the United States, you might go to one of our stores and have the ability to do everything you want to do, but then you go to an airport, and that's owned by a completely different company, and you can't do all of those things. We have to fix that, because all you know as a customer is you went to Starbucks. It doesn't make sense for you to have to think about, well, is this one that's company-owned versus one that's licensed, and all of that kind of stuff. So we're working on the rewards platform. We're also working on the mobile order and pay platform, where you do the mobile ordering with your phone. And we have to build everything from scratch. Everything. We have to build all the processes. We had to build all the infrastructure, all the code, obviously, the services that we built. And we went into production, and our management said it was flawless. I've never been called flawless before. And a lot of that had to do because we were using Scala and using tooling that really helped us build smart software. We came in pretty hot. We did not come in with everything fully tested as much as we wanted. There simply wasn't time. We had a date that we had to hit. And because of the correctness of the software we were writing, we felt confident that we knew we were meeting our business goals. And we did. So that felt really great. Now, as I was saying, I don't personally want my team to write really complex software. They're new to Scala still. They've been doing it now for a year. They've gotten some really good experience. They do some pure functional programming with Kleisleys, and they use Monex and other parts of cats, but they don't write free monads or anything like that, or tagless finals for sure. We're just not at a place where we want complexity in our software where we don't need it. We try to keep things as simple as possible. And that's worked well for us because we have clarity in our code as a result. Sometimes in Scala, because things aren't encoded as very specific types, you don't always know you're using a pattern unless you know the pattern well enough. Like just type classes, right? If you're not using simulacrum, you don't know that you're necessarily looking at a type class unless you know how to recognize it. So with my team, I don't want them having to think about writing anything complex if there's a tool that will solve it for them, right? Just like libraries that we talk about, like Monex, if we're going to use streams or something like that. It's a very simple little stream. Why not use Monex? It's great for that. So let's just leverage things where we can. And for the business, we have only one database that we can leverage, Cassandra. And you could say, well, why is that? Part of that has to do with the fact that we built a platform as a service over AWS. And we get certain components as infrastructure as a service. We get Kafka, we get Cassandra, we get Kubernetes, we get Vault. And these are provided to us, so my team doesn't have to operationalize them, but we do have to configure them and run them in production. So they're given to us by the people who created our platform. It's a highly automated infrastructure as code platform, security by design, all of this really great stuff so that we can deploy into a market with an immutable deployment in minutes. That's the goal, and it's great. But it also means that all I get is Cassandra. And Cassandra's great. Is Yuhai here today, this morning? Is he around? No. Oh. He's from Datastacks. He's running around. I met him last night. Really interesting fellow. And when you only have Cassandra, that comes with its own trade-offs, right? Cassandra's really good at certain things. Storing large amounts of data. We've all heard stories about Apple. 3 or 4 years ago, they had 75,000 node clusters of, Cassandra. And I think they had 2 of them. It was huge, right? And that's fantastic. You're almost creating this place where you can put all this data. But it comes with its own semantic drawbacks, right? If you're dealing with a Dynamo-based paper or Dynamo-based database, you know that, say you've got a 5-node cluster, and you set your write quorums to be 3 nodes because you don't want to set your write quorums to be 5. Then you're saying that it's got to write successfully to all nodes, and then you've got to deal with the potential that not all nodes can agree, right? So you say 3 of those 5 is what you're going to accept as a valid write. But when you do that, you don't know what node is going to be read from. And so you can get stale reads. Has anybody ever come across this? It's not much fun. And you see people out talking in various circles about how we have to let go of the idea of consistent data. We have to accept eventual consistency when we're dealing with microservice architectures. And I say, okay, yeah, that's true. But when we talk about an individual service with its own isolated data storage, do I really want eventual consistency all the time there? What about when I've got source of truth? Right? I've got certain components in my system which are the source of truth for all of Starbucks now. And that's difficult whenever I say, well, hey, you might get an old read without the latest update. In particular, if I look at the business problem for Starbucks, think about the rewards platform. Somebody comes into a store, they use their phone, they order, a latte or something like that, and then they accrue points. Right? They get points added to their account for that purchase. And then they say, oh, you know what? I would like to buy somebody else a coffee or something else to go, maybe a food item or something like that. And they say, I'm going to use the points I just got, except they can't see them because they're not getting visibility to the fact that the write transaction took place, but the read hit a node to which Cassandra hadn't gossiped that information yet. And at some point, yes, it will, turn out to be consistent. You just don't know when that will be. And so that's kind of tricky. And to the business, they say, well, we don't want that. That's a bad customer experience. We cannot let go of the idea that we need a fully consistent view, a strongly consistent view of our data when it comes to rewards points. And so we said, oh, really? So we tried arguing, and it didn't work. Because we sell a product that's roughly €5 every time you buy it. And you say that's expensive, but Starbucks does some really great things around the world, and I feel good about that, right? But we don't sell, any products that are $50,000 or €50,000 or anything like that. So every time we let go of a transaction, a potential sale, or give away a free drink because systems are down, that hits our bottom line directly. This is one of the number one reasons why my whole project exists. It's too costly to our business to give things away for free, and we do it a lot right now. Just because system goes down, you're unable to do a transaction, they give you the coffee. It's a running joke. If there's an outage at Starbucks, everybody runs there and get a free coffee. So we think that's funny, but at the same time, and we want people to have that routine. We want to make sure that they are coming back, so we aren't going to turn people away. but at the same time, it really hurts us as a business. So Cassandra doesn't solve all of my business problems, and I've got to figure out how I'm going to deal with that. And I just want to go through some of the basic concepts of database theory, and starting with the CAP theorem. I am not a research scientist on databases. I read white papers and stuff like that, but I am, like I'm sure most other people, I have to sit there and read them and try and figure out exactly what people are talking about. And sometimes, and I have a story about this, I don't understand what people are saying and I completely miss the point. One of the things I like to ask people whenever we're doing interviews for jobs is, hey, have you heard of the CAP theorem? Because it's sort of the base level for distributed systems. It's like the entry-level point that we all start at, and just to get a feel for what they know about it, what they've heard about it. And it's, pretty straightforward. I think at first, maybe 10 years ago, people started talking about how it was a trade-off between three properties, right? The consistency and availability in the face of a network partition, until we all really thought about it and said, oh, wait a minute. Thank you, Eric Brewer, for clarifying all of us who got it wrong. It's really the choice between consistency and availability in the face of a network partition. You don't get to choose partitions. They happen. So you get to, if you have a one-node database, you can be fully consistent because you don't have to worry about sharing it across any other nodes. But if that one node goes down, you're no longer available. If you want availability, then great. You're going to have to go across multiple nodes. But now you've got a problem of eventual consistency because physics, the speed of light. There's no way to guarantee that you're going to have multiple nodes all agreeing consistently that this is the right value for an update. So, CAP theorem really influenced the way a lot of us thought for a long time. You saw databases like the Dynamo paper came out and DynamoDB on Amazon. Cassandra follows the principles of the CAP theorem, trying to be available in the face of partitions in a distributed way. Reac was another one, a key value store that I used 5-6 years ago at a large cable company, and it was very successful for us. So, there were a lot of databases that implemented the basic premises of the CAP theorem. But then, around 2014, Eric Brewer, the person who wrote the CAP theorem, started saying, maybe we were wrong. Maybe we weren't quite right about this. Maybe it isn't as binary as we thought, consistency or availability. What if it's more of a sliding scale? And again, whenever he came out with this, I didn't quite understand what he was talking about. And I tried to read the InfoQ article that came out. There wasn't a white paper at first, I don't think. And I didn't understand what he was talking about. I was thinking, hey, well, yeah, it is kind of a sliding scale because you look at quorums and stuff like that. I could say that I want to write to all 5 nodes, all nodes in my Cassandra deployment. And then, I'm trading off a sliding scale of consistency. That wasn't what he was talking about at all. He was saying that we're actually kind of optimizing in the wrong direction. And more people started saying, what do we really mean when we're trading off consistency and availability? When I say we're optimizing for the wrong case, the tricky thing about this is we're sitting here and making data decisions entirely based on whether or not a database is going to go down or a network partition is going to occur. And we're saying we can't have that happen ever. We're going to have our database be up all the time, and that's going to be fantastic. And yeah, great, except one small problem. Does anybody here have a database that's never gone down? One that never goes up, exactly. Yeah, we sit here and say that we're going for availability and everything, except we don't actually have it. So have we been optimizing in the totally wrong direction? If we don't have availability, then why are we giving up so much consistency? So I started thinking about this. I'm like, oh, that's kind of smart, actually. Because, yeah, why am I sitting here and trying to pretend that I have availability? I don't. All right, so a fellow named Daniel Abadi. Has anybody ever heard of Daniel? Okay, awesome. I could tell a great story, too. Daniel came out with this paper called Calvin, like the philosopher Calvin. And in it, Daniel started talking about a different approach for thinking about CAP. He said it's not enough to say that you're trading off consistency and availability. And Daniel also said that network partitions are rare. And when he said that, he completely lost me, to be honest. His point was, if there's a partition, how does your system make trade-offs between consistency and availability? You know, if a partition occurs. However, when there isn't any kind of partition taking place, your database is actually making choices about latency and consistency. Like how much time it's taking to be consistent, strongly consistent. And when I say strongly consistent, I mean that I know if I hit a node in that distributed store, I'm going to get the latest update. So I started thinking about this, and I actually met Daniel in about a year and a half ago. I was with Lightbend at the time. I still do that. I was with Lightbend at the time, and they sent me to China because Huawei had asked for Martin Odersky to go, and they got me instead. So that happened a lot, actually. Because, I mean, Martin's really busy, and he can't go everywhere, right? And he'd been to Huawei once already, so this was the second trip to Huawei. They got the B team, you know. Anyway, this was an amazing conference. There were like the chairman of the Databricks company who was the head of the AMP lab at Berkeley where they came up with Spark. There was Daniel Abadi, a whole bunch of academics, and also a whole bunch of people in industry. Monica Beckworth was there. It was great fun hanging out with her. If anybody doesn't know her, she's like the person who did all of the performance tuning of G1 GC for the JVM. Brilliant. Anyway, Daniel gets up and he starts talking about a file system, a distributed file system based on the Calvin paper. And he starts talking about PAC-ELK, and he mentioned that network partitions are rare. And I was like, no, they're not. He's like, yes, they are. No, they're not. I'd worked at Juniper Networks, and to me, rare was not the word I would use to describe network partitions. We would see them all the time. But Daniel made a really good point that at the time I didn't understand. So here I am arguing with this really brilliant researcher, because I'm a jerk. And what he was saying was, yeah, okay, they happen every couple of minutes. But think about that in terms of the number of transactions you're trying to run against the database. What percentage of transactions are affected by a network partition? I was like, okay, yeah, that percentage is kind of small. And I was like, all right. So he is arguing that if we're giving up consistency for availability, we're optimizing in the wrong direction. We can have our consistency. At the times when there isn't a network partition, we can do that. And then whenever a network partition occurs, we can make the choice toward availability type semantics and give up that fully consistent view, right? It's just a matter of, okay, how are you going to know that's happening in the database or in your application code? Because if you're trusting a database to do this work for you, you're implicitly saying that I don't want to write in my code all the logic to make sure that I have a non-stale read, right? So that was kind of tough for me. But at the same time, I get it. Why am I giving up all of my consistency given that I don't have a database that is 100% available? So I shouldn't. Now, to get a little deeper into the data management taxonomy before we start talking about the solutions that are coming down the pike in this regard, I want to make sure that everybody's on the same page as far as what each of these words mean. This might be, really basic for a lot of you, so I apologize for that. But how many people feel really confident being able to describe what consistency means in ACID properties versus consistency in the CAP theorem? Anybody? I didn't. So I started really trying to understand exactly what that means. And I can read you exactly what it says on Wikipedia. But what consistency in ACID transactions means is that whenever I have a transaction, that my database is going from one valid state to another valid state. Right? That has nothing to do with distributed systems. It's just saying that whenever I have a data store of any kind, that I am transitioning from one valid state to another successfully. Consistency on the CAP theorem, though, is talking about, am I getting the same value whenever I hit multiple different nodes in a distributed store? So just understanding that basic concept is really important. And then you heard me say strong consistent earlier. When we're talking about strongly consistent, that's when I have the guarantees about consistency in a distributed database. And one of the people who has done really tremendous work in this regard is, Kyle Kingsbury. Everybody's heard of the Jepson series, right? Has anybody not heard of the Jepson series? Don't feel bad if you haven't. Go out and check it out. So Kyle Kingsbury runs around and he gets paid by people to destroy databases. And sometimes they're quite funny. Like, I think in 2013 he wrote his first Jepson series review of MongoDB. And it was ugly. And he did Redis, he took apart React, he took apart Elasticsearch, and we all got a good chuckle about, ha ha ha, look at that database I hate personally is, crap. Except what Kyle was really trying to accomplish was not to be a troll on the database world, but to try and help those database companies make better decisions, right? If he knows that there's going to be issues with a certain database, how is he going to know exactly what to do in his application code to withstand those kinds of failures? So that helped all of us. And really, what he started doing in the last 3 years is working with database companies to help them pass his series of tests. So now, believe it or not, MongoDB in February of this year passed the Jepson tests. And anybody who sits there and says that Mongo is going to fall apart and not give you consistent data in a distributed view is wrong, so long as you're using the right version of its replica strategy, its replica algorithm. That does not mean that if you're going into a sharded view of Mongo, that you're going to have the right semantics. It's just purely about replication and consistency. And it also does not mean that at load you're going to see this specific semantics. That's a really important thing to think about. Jepson makes no claims about load. So when I talk about data serializability, I'm going to be kind of pithy, if you will. But to me, you could sit there and look at it on like Wikipedia and read paragraphs and paragraphs about what serializability means in data context. But for me, it's really about right order. Can I guarantee right order? In a distributed database, that's really important. Like, I want to be able to say what happened before what else. Think about it in terms of that rewards project that I was talking about, where somebody comes in and they order, and that increases the number of points that they have, and now they can actually do a transaction to redeem and get a free beverage or food or whatever. If that was in the wrong order in my database, then I really couldn't do the transaction, because I'd be trying to redeem before they'd gotten the points to actually allow them to do that. There you are, UI. Anyway, that's kind of a problem, right? And there are certain things that I can't do anything about. Like, I can't say I have to be sure that this event happened, it reached the database before anything else, right? But once it's gotten to the database, can I have order? And that's what serializability is about. Linearizability is that all nodes agree on order. So if I'm saying that with serializability, I have a guarantee that A happened before B. With linearizability, I'm saying I've got all these nodes out there, and they're all agreeing that A happened before B. And then you get into linearizable consistency. And this is where I'm starting to talk about, do I ever get a stale read, right? Am I ever seeing data that is not the most up-to-date change to the database? So once I know these things, then I can start thinking about, all right, well, how is that being accomplished? And how many people feel really comfortable with the ideas of optimistic and pessimistic locking? Jean, a couple other people. It's just the idea that if I'm pessimistic, I'm going to go out and put a lock on something, and then I'm going to do whatever I want, and then I'm going to apply my change, right? When I'm optimistic, it's much more like compare and swap, where I'm saying, I'm going to read, see what the value was, I'm going to make an update to what I was doing, and then I'm going to look to see, was it changed before I try and do my right? So compare and swap versus saying, I've got this and nobody's allowed to change it. Optimistic, pessimistic. And believe it or not, these aren't changing very much, right? We all say we want to be lock-free and stuff like that, but when it comes to data, nobody really wants to let go of those kind of semantics because they're too powerful. It's too important whenever you talk about consistency. However, I started thinking about this, and I started realizing the way I was looking at consistency and availability was almost like optimistic versus pessimistic. Availability being a pessimistic view. The database has to be up all the time, so I'm going to try and make sure that it is, and I'm going to give up consistency in order to have it, right? But I shouldn't have to really do that. So let's start looking at a couple of the solutions out there, and this is where we start getting into the fun part of the talk. There are a lot of tools out there that are coming out, and there's a lot of talk about, but the real question is, what are they based on, and what theories are they using underneath to try and give you all of the kinds of data semantics that I was just talking about? And there's already like 5 of these out there. Now, most of them are cloud-based. How many people are allowed to put their data out into another cloud? Like not your cloud, but like somebody else's, like entirely different database cloud. Yeah, that's kind of weird. And the thing that always scares me about this is, at Starbucks, in some ways, we're actually kind of a bank. If you're a part of our rewards program or you're doing mobile order and pay, you have to download money onto your store value card. That's what we call it. So that happens on the order of $7 billion a year for us. It's a lot of money. So we take security pretty seriously because we've got a lot of people who are making sure that we are talking about, have you ever heard of PCI DSS version 3.2? PCI compliance is a really big deal in security. In the US, we have SOC 2 Type 2. Another thing you'll see is whenever you say to a cloud vendor, hey, how seriously do you take security? The one way you can ask and find out is say, do you have a CAIQ? And what that is just a questionnaire that people fill out and say, I have thought about this, I have thought about that, and I have done this about that. And when somebody hands you a CAIQ, it means they've thought about security. It shows that they're at least thoughtful in the way they approach security. And then you have things like OWASP Top 10 and stuff like that as well. Well, not everybody is really PCI compliant. So I can't move my data into a cloud-based solution in a lot of regards. I can't, because I don't have the guarantees of security that I need for our data, because we take it seriously. So let's look at Amazon Aurora. Has anybody ever heard of Aurora? Yeah, it's MySQL in the cloud. Literally, it's MySQL, and being packaged is a completely different database. When we look at Amazon Aurora, one of the really cool things about it is that Amazon is giving us guarantees around its availability. 4 nines. 4 nines isn't bad. If you look at SLAs that you get from large companies, 4 nines is actually kind of rare. Most companies are going to tell you, hey, we guarantee 2 nines, 99% availability. But if you think about that in terms of how much time that actually means that they're guaranteeing you, they're giving up 3.5 days a year. I don't want to be down for 3.5 days a year. So 99.99 is a much more strong, guarantee from Amazon. And when they break these SLAs, then, there are penalties. They've got to compensate companies like Starbucks for having broken the SLA. So that's a big way to stand up and say, we are guaranteeing you this is going to work. And because it's MySQL in the cloud, you can kind of lift and shift into Amazon Aurora. You can do a data migration and maybe not have to change much of your code because you could still use JDBC to access it, right? One thing that's kind of tricky about it, though, is that it isn't really one of these databases that is taking a completely different approach to consistency versus availability. It's just MySQL. So it still has those basic fundamental issues around the fact that it's one single write master. And then the replicas are eventually updated, which means you haven't really gotten consistency at all, because those reads aren't guaranteed to be linearizable consistency. So that kind of stinks, actually. It has quorum read-write, but it's just really redundant writes across availability zones in Amazon. And because of this one single write master, you're limited to the amount of performance you get from however big that box is that you deployed the master to. So yuck. Yeah, okay, well, that's got a couple other trade-offs as well. It doesn't just mean that I've got to keep getting a bigger and bigger box because of my database load increasing. But if I need to shift to a new master because I got another, whatever you call the largest instance on Amazon today, now whenever you go to, migrate to it, you actually have to shut down your database. And that's on you. That's not their SLA. That's you because of what you're doing to maintain your environment. So that's kind of a bummer, actually. Now, you get throughput, but at the cost of latency because of pessimistic locking in order to try and avoid that linearizable consistency issue around eventually consistent replicas. You have vertical scalability instead of horizontal. That's where I'm talking about the larger node in order to try and get faster. We want horizontal scalability. You add a node, you get X amount more throughput. And you don't get sharding with Aurora. So the problem with not having sharding is what happens when your data set exceeds the size of your write master. Like, you need to be able to shard your data if you're dealing with really large numbers of, say, your customers. Say you've got customers all over the world. Say you're Facebook, and every person needs to be, in a database. Well, okay, but I can't fit them all in one node. So I've got to shard the data, maybe by region, maybe by name, maybe by, I don't know, whatever your strategy is. And you don't get that with Aurora. So, Now, how many people have heard of Microsoft Cosmos? UI. By the way, he works for Datastacks, so he knows a thing or two about databases. But with Microsoft Cosmos, you're actually getting a certain level of declarative consistency, and this is where you do see a database going in the direction of trying to get away from the basic CAP theorem principles that we had to begin with. Cosmos, now, Aurora, because it's Amazon, it's only available on Amazon, of course. Cosmos is only available on Azure. And, it was based originally on that document DB, which is very much like a MongoDB kind of implementation. It's a document store, And the cool thing about this is where we're starting to say, I can have global database infrastructure, and I'm getting guarantees around consistency, even though I am spanning the entire world. Now, these sort of things sound to me like, a Google problem. Like, only Google actually has this problem. Because for me, and probably for most of you, how many have ever heard of the term GDPR? Global Data Protection Regulations. Yeah, here in France and Germany, I can't have French people's data, or people located in France anyway, in a database in Germany, right? And I can't have people in the US have, all the data of people in France. Like, if it's any way, shape, or form identifying information, I can't do that. So I don't have this problem around needing to solve a global database, infrastructure solution. That's just not a problem I have. When we deploy to France, we're going to have a deployment specific to France. Same thing with Germany, same thing with the UK. We're live in Japan. We're not going to have databases located around the world. They're all talking to each other. That's just not going to happen for us. And I don't know if that's true for most of you as well. Probably. But Cosmos does offer ACID semantics, transactions. It can do graphs and key value. Key value is actually the starting point, believe it or not. That's the easiest kind of database to really do, is to have the idea of key and whatever kind of crap comes after it, right? And one thing that people kind of lose sight of is, in some regards, Cassandra is very much a key value store because you can't really do lookups on non-indexed values very easily. So, but it has a declarative consistency model. You get to choose how consistent you want that database to be. And you can turn the knobs all the way to 11 for that global footprint and have fully consistent data around the world, which is kind of cool. If I had that problem, I would think I'd really want that. But you also don't get any uniqueness or foreign key constraints, and you don't get distributed transactions, which is always the big problem, right? Does anybody here remember XA? It's just me, I'm old. All right. The whole idea, for years we thought, oh, we can have distributed transactions, and we never really did. But you also don't really get a distributed group by yet. And anybody who's ever even looked at Scala and you did a group by on, say, a set of numbers or something like that and said, give me all the ones when you divide by 2, that are even and odd, right? The ones that have a remainder of 0 and the ones that have a remainder of 1. That's a really useful feature to have. But also, if you know Scala, it's probably kind of slow, right? Because it's a painful operation to do. It's totally totally recalibrating the data into a completely different view. So Spanner, this is the one that got everybody really excited. This is what Eric Brewer was working on at Google. How many people have heard of Spanner? All right, so yeah, this is the one that everybody's heard of, and it's really exciting, right? And this is where we were saying, all right, we really can do global consistency, and you don't even have to worry about tuning it. It's just going to happen. No matter how big your footprint is, you're going to get to do this. Is there a question? Or no? Oh, I'm sorry. So with Spanner, we're saying, again, globally distributed, consistent data. But again, we get this vendor lock-in where it's only available on Google Cloud Platform. And because, where Amazon, you were using MySQL and you knew that you could pretty much just kind of lift and shift your code over. You could say, I'm just going to point over there instead of over here, and now I'm using Aurora instead of my own SQL database. Google Spanner is a completely different approach, and you're going to have to completely rewrite anything you have to leverage it because it's got its own client libraries and stuff like that, or its own interfaces that you have to adhere to. And one of the things about it that kind of drives me crazy is that it's got true time, which is amazing. It sounds incredible, but I can't find out much about it because this is the proprietary secret sauce that allows them to manage their snapshots and synchronization across all these nodes around the world. What Spanner is in essence doing is saying, I'm going to receive in updates that are just coming in all over the place. And then at the leaves, where we're looking at the data, where we're trying to do our reads, I'm going to use true time to figure out what order is and consistency. Because using true time, they're getting away from the idea that I care about clock time. And you saw this, you see us trying to do that with things like vector clocks and CRDTs and stuff like that. We still struggle with that. We still can't get these things to be 100% provable. But true time apparently can. But they won't tell us enough about it. So it's like, come on, guys, share. But no, they won't. That's their secret sauce. And it's also using pessimistic locking, which they can get away with because Google has a network that we don't. That kind of sucks when you think about it, right? Why don't we get that network too? To some degree, they are giving it to us. You see Google going out to various cities around the world and saying, hey, would you like a super fast WAN? And so he's like, yeah, me. Right? They're all asking for it. And then Google also does some really amazing things like in Puerto Rico where there was the Hurricane Maria that hit and totally obliterated the country, and there's still 90% of the population without electricity at this point. Google is flying balloons over Puerto Rico to make sure that they have internet connectivity at the very least. Their phones aren't charged, but they have internet connectivity. And I mean, that's pretty amazing. Nobody's paying them to do that. They're doing that to try and help the community. But either way, they've got a network we don't. And that's how they can use pessimistic locking. Like when you're saying, I want to use pessimistic locking, you're making the choice that is going to hurt your ability to do more reads. Right? You're not going to be able to do writes as fast. You're not going to be able to do writes as fast because you're always doing all this grabbing and saying, this is my data and nobody else can change it until I'm done. Right? Optimistic locking is something that can be overwhelmed by the amount of writing that you're doing, just like compare and swap or software transactional memory. Anybody here ever use SDM? Yeah, it was a failure. So anyway, Google Spanner is offering 5 nines of SLA for availability, which is, I've never heard a vendor say I can do 5 nines, right? That's crazy talk. That's like you're only going to be down, I don't know, 3 minutes a year. Okay, I like hearing that. And if they break it, again, they've got to compensate me for what I lost as a result of it to some degree. It's all lawyers and contracts, and I spend way too much time dealing with it. So Spanner and Cosmos are offering very similar guarantees around throughput, latency, and consistency, right? The SLAs I'm talking about are uptime, really. But it's pretty interesting to me that despite the completely different ways that they're implemented, Spanner and Cosmos are saying, hey, you get the exact same guarantees. These are SLAs. And I wonder sometimes how much of that is marketing, right? Well, if Google's offering this, then we've got to offer that, or vice versa, right? You know, if Microsoft's offering that, then we've got to offer this. Either way, the customer kind of wins. But I still have that problem. I'm not on Google, I'm on Amazon, so I can't even use this if I wanted to. Tough luck, right? Oh well. So what am I going to do? I've still got this problem where I've got to be able to, you know, have my points stored in a completely consistent distributed view. What am I going to do? So I started looking around, and there was an open source solution. How many people have heard of Cockroach TV? Cockroach DB is pretty much the open source implementation of Spanner. Fantastic. Except TrueTime isn't there, which sucks, right? And think about this in the open source community. Here's a wonderful solution that's been developed by people working awfully hard. But then they come up against this problem where they can't disambiguate order because they don't have access to that secret sauce of TrueTime. And what they end up doing is using NTP. And if anybody knows what that is, it's local to a specific machine around time management, and it drifts, which means that you can have a machine fall 200 milliseconds completely away from, you know, all the other machines, and they have to come back together. And in order to do that, they have to use a protocol. I was talking to Yuhai about this yesterday, that, you know, means that you're never going to see your reads quickly. There's always going to be a latency cost, which sucks. The good thing is that Cockroach DB passes the Jepson test. If you need a database that is going to be distributed and consistent, and you're willing to pay the latency costs, which I haven't personally evaluated, but as I understand, it's roughly 200 milliseconds per read. Wow. That's a lot. I can't do that with my customers. Unfortunately, that's not an SLA that I'm allowed to give out. So I have to be faster. And so Cockroach wasn't an option for me. But hopefully, Cockroach can get past this, or if you don't have the latency considerations I do, this is an excellent solution to try. It passed all of the Jepson tests already. So Cockroach is viable. It's exciting. And now we get to FaunaDB. How many people have heard of Fawna? Okay, yeah, you, hi. And Daniela. And Cockroach and Fawna are the two that you can use no matter what platform you're going to run on. You can use it in-house. Fawna also has their own cloud-based solution that you can leverage, but like I said, who cares? This is interesting because anybody who was here for my talk last year where I was talking about OSS being in danger, right? We're starting to see the effects of this. The choices where companies have been told by VCs in order to create a product, they've got to come up with some cloud-based solution, because once you say cloud, I mean, who doesn't get excited? Woo! They haven't been successful. And so that means now a lot of open source companies are becoming closed source. A year later, we are seeing the effects of this, where companies like Databricks or Datastacks are no longer contributing to the open source projects that they were originally supporting. They aren't, at least to the degree they were before, because now they've just got to come up with proprietary solutions. Fawna itself is a proprietary solution. It's closed source. You can't get access to its code. There's nothing you can do. But that was a business choice they made. They said, we're just not going to fight this battle. We're going to try to build the right database. And if anybody knows the history of Fawna, Evan Weaver is an engineer who was at Twitter. And he and I both come from a Philadelphia tech community that is kind of tight-knit. I didn't know Evan before he'd come out to Twitter, left the Philadelphia area and went to Silicon Valley. But I'd heard about him. And I knew people who knew him, and they, you know, you're talking about some brilliant people saying how smart this guy is. And there are people out there who say that Evan is the person who saved Twitter, because he was the one helping them get on the JVM and solve their data problems whenever they were constantly getting the fail whale. I wouldn't say that he did it alone. That's ridiculous, of course, but he does get some credit for it. And what Evan said was, after I left Twitter, and let's face it, he made some money on the deal because they went public, he decided, what if I had the opportunity to, instead of all the individual databases we had to throw together, and you see several of them like FaunaDB and stuff like that, if I had the choice to take all of that and come up with one generalized solution for everybody, what would that be? And so he started digging around. He came across the Calvin paper by Daniel Abadi, and he said, this is a pretty smart idea. What the Calvin paper was really saying was, I'm going to write all of my data into a distributed log. And this should sound very familiar to everybody because that's, in essence, Kafka, right? It's just writing everything into Kafka, not literally, but semantically. Disambiguating order in that log, and then pushing out to all the read nodes. If you hit a node for a read, you are guaranteed order. You are guaranteed consistency because it's already been taken care of. Does that mean it's free? I mean, as far as like, time-wise, no, but they are pretty confident that they can have 10 milliseconds of latency as opposed to, hundreds of milliseconds of latency. And those are numbers I can personally live with. I'm not doing high-frequency trading. Nobody is going to sit there and accrue points and then try and redeem them in milliseconds. We can't move that fast, thankfully, right? I mean, it means I don't have to deal with some of the really hard problems that other institutions like banks might have to deal with. So FaunaDB became really intriguing to us. And the great things about this, you get transactional semantics with single-phase commit across thousands of records and indices with an optimistic approach, not locking-based quite so much. You have the serializability using Raft, the Raft protocol, to figure out that order exists. Linearly consistent, like I said, I get strong consistency on my reads. I know I'm going to get the right data whenever I do a read. Hierarchical row-level authorization. It turns out that that's really important to my company, believe it or not, because think about the idea of licensees. Here in Europe, AmRest is the company that runs most of the Starbucks, not us. So that's almost a tenant on our platform. And if I can have tenancy built into the database without me having to write all that code myself, fantastic. Multiple indices, so I can read based upon different kinds of values. Temporality, which is great for being able to do auditing and having a coherent cache or being able to roll back a database. And it also supports graphs. But, this is not a mature solution per se just yet. First of all, it's closed source. So that personally pains me because I know there's so many brilliant people in rooms like this that would have great ideas to contribute to a database like Fawna, and you can't. Right? Transactions themselves are limited to a single function. When I say that, you cannot say, I want to do this transformation and then apply the next transformation. Every single one of those has to be a unique transaction. But hey, that's better than not having transactions at all. It has its own query language, which is somewhat limited and arcane. It's not perfect. It's very much like the idea of what you see in Slick or Link or other, type-safe functional query approaches, but it's not. It's not the same thing that you couldn't just know Slick and be able to apply it to this. You couldn't just know Scala collections and be able to apply it to this. There are different semantics to some degree. And, as a new product, there aren't a lot of people in production. NVIDIA is using it in production and have been for some time now, actually. We're personally trying to get an audience with their team to get a sense of what it's like to operationalize this ourselves. How hard will it be to run this in production ourselves? We have stood it up ourselves in our cloud platform to get a feel for what that's like. It's up, it's running, it's working. We're doing load testing with it. Everything seems to generally work. We came across a bug. They sent us a fix. That, of course, makes the company nervous because we're big, we're huge, we're Starbucks, and you hear, wait a minute, they sent you a patch? Well, yeah, believe it or not, everybody sends patches. That happens. But still, there's just a certain amount of fear in an organization like Starbucks about adopting something completely new. Capital One is also, I think, looking at this, not publicly or anything like that, just anecdotally, people talking amongst each other. Cap One, they've been doing some really amazing stuff, by the way. You see them with Flink. They've been very involved in the big data community. they take it very seriously. They're huge as far as credit card processing in the US. And so they're looking at very unique solutions to try and help them solve their problems. It's not verified by Jepsen. And whenever I talked to Evan about this, I said, that's kind of a problem. And it wasn't because I didn't trust Evan's level of testing. It's just that Jepsen is now, by default, our standard for database, replication. This is the only thing we have to say this is a proven suite that everybody kind of agrees with. And what Evan said was, here, look at our tests. We think they're actually stronger than Jepsen. And it's not like, Evan and Kyle are friends, so it's not like, this is a competition thing or anything. It's just Evan wanted to be more stringent about what he was trying to achieve. But if they'd at least run the Jepsen tests against their database, then we could say, yes, they passed that as well, and we did this much more. And my real problem, what if it disappears? Does anybody remember FaunaDB? You, hi. A couple other people. FaunaDB was a database that, 2014, 2015, was getting real traction, and all of a sudden Apple came in and bought it. And they were open source, and all of a sudden that meant done, disappeared. I mean, the code is still out there. You can find the code up until that point, I think, or did they take it down? Yeah, it's still out there on GitHub. But anybody who was using it suddenly got cut off. It wasn't like Apple was sharing the changes that they were making to FaunaDB going forward. It went closed source. RethinkDB, a database that went under, an open source database that went under about a year ago. Riak, Basho, failed, 3-4 months ago officially, but I think people had felt that it had fallen apart about a year ago as well. Open source database solutions really struggle as far as making money. Why? Because it's hard to sell things that are free. I mean, that's just the way things are. So for Fawna, they made the choice to be closed source. Great. Now I have to pay for it. And we've even paid them to do our proof of concept inside of Starbucks. But what happens if they disappear because of acquisition or whatever? That's a real risk. So I can't use Fawna everywhere inside of my application. I can only use Fawna in a very limited space, because then I could say, if anything were to happen, I only have to change my point service or something like that to get back to Cassandra and be able to operate again. But if Fawna really does everything that we hope, wouldn't that be great? Because then, in my application code, I don't have to fight for consistency. I don't have to have my team writing things like consensus protocols. I can just let the tool do its job, and my life gets so much easier. So, I'd hope to give you, the idea that we made a decision about this by today, but we haven't. We're still probably a week away for various reasons. We were going to make a decision yesterday, actually, and it turned out we didn't have a quorum for the people to make the vote. I don't make these decisions. I make my developers make these decisions. The people who are tech leads on my team vote. They have to own it. They have to be the people who are standing up and saying, I have enough information to make a decision here, and we as a team are going to agree. It doesn't have to be consensus. It does have to be majority. And so they didn't make the vote yesterday because we didn't have enough people to vote. Where were you people? This was a big day. I could have walked in here and said, we've decided to use Fawna, we're doing it. No, don't know yet. The jury is still out. So we'll see what's going to happen, and I don't know, I'm going to try and talk about as much as I can on Twitter, if anybody wants to follow and find out. So, Cassandra, back to this story, right? Wither Cassandra. One of the interesting things that's happening right now is my talking about FaunaDB publicly has really stirred the pot at Datastacks. There have been multiple people contacting me and saying, hey, it's really interesting what you're talking about there. You're getting a lot of internal discussion going on inside the company. Like I said, Datastacks is focusing less on the open source Cassandra solution because they've got to make money. They've got to succeed as an organization that's taken a lot of VC money, right? So that's a position where we don't necessarily know where Cassandra is going, and I don't want Yuhai to stand up and tell us all, company secrets or anything like that. I'm going to have a meeting with the Datastacks, sales team, honestly, where they're going to talk more about their roadmap in the next month or so. But it's going to be very interesting to watch what happens with Cassandra. because they know that the database world is changing right now. And while Cassandra does amazing things in its current form, holding tons of data, more and more people want that consistency in a distributed context. So let's watch and see what happens with Cassandra, because I mean, it's probably the most proven of all of these solutions at scale. And that's my talk. Does anybody have any questions? Yes? Okay, so the question is, how about buying out FaunaDB? Okay, so Starbucks is not a technology company. And one of the really cool things about this is, I mean, would we buy Fawna someday if it was such critical infrastructure? I'm not saying that that's entirely off the table. But at the same time, I don't see Starbucks wanting to be the company that would go out and buy a company and then close source it. I mean, one of the things we take very seriously is being good in the community. Like that is one of the most important things about Starbucks. As a company, yes, we have to make money. But when we do, in the US, college education is ridiculously expensive. Anybody who works for the company gets a free college education if they want it, completely free. You know, you hear about healthcare in the US being ridiculous. My healthcare actually isn't that great at Starbucks because we're subsidizing the cost for all of the people who can't get it as baristas unless, you know, they had a plan like ours. You know, we pay more for coffee than we have to. We don't pay market rates because we want to make sure it's sustainable in all of these countries where, you know, there isn't a guarantee of income, right? So, one second, Yuhai. So there's all of these things that we want to do the right way. And it wouldn't be hard for me to tell the organization, this is a bad thing to do, to take a database like Fawna but then again, it is closed source already. What am I even talking about? Anyway, yeah, I just can't see us doing it. We're not a technology company. We're still making baby steps, but who knows?
Does Starbucks has an engineering blog post where we can see the progress of testing Fawna?
So the question, you know, does Starbucks have like a blog, a tech blog, or anything like that where you can see the progress of what we've been doing here? The answer is no. So up until 2:30 a.m., I was still editing my slides to meet marketing communications guidelines. Yeah, you know, we are hyper brand conscious. The only people allowed to speak at Starbucks is the CEO, the former CEO, Howard Schultz, who's sort of like our Steve Jobs of coffee. The CTO occasionally goes out and speaks. I just saw her give a talk at a Gartner symposium, you know, but she doesn't do it very often. Other than that, it's me. So yeah, like they do not let people talk publicly, and when they do, they get really nervous about it because this is our brand. Like, let's just go back a few slides here. I used to have like a little Starbucks thing on every slide because they said to me, you have to put a trademark by every single one of them. This. And rather than go through every single slide and add that little TM, I said, I'm taking it off, right? The first and last slide, I had, you know, the Starbucks logo kind of tilted, peeking in from the side. And they're like, that is not a standard logo. Okay. But, I mean, when you see a company like Starbucks or Apple, or I was wearing a Netflix shirt yesterday, the reason these brands resonate so strongly is, let's face it, they're very controlled brands around the way they manage their, you know, image. And they do a good job of that, but it also means that there is no technology blog. In my group, which is a transformative group inside the company, and because we were successful, we have a lot of backing right now, like, which is so cool. Like, Starbucks is just asking us, what do you need? What do you need? What do you need? Let's do more, right? They're just so excited about this. I think in time, we will have a technical blog. But I am openly discussing on Twitter what we're doing, because nobody's told me to shut that down yet. Hopefully they don't see this video. But I mean, it is very highly managed, but you'll notice my Twitter account does not say I work at Starbucks. It's just everybody happens to know that. You know? Any other questions? All right, well, thank you.
Thank you, Jamie.
I forgot to mention one really important thing that ties this all together. FaunaDB is written in Scala. It is, like, almost entirely written in Scala. So this is a really cool thing. This is another possibly transformative infrastructure piece written in Scala. Kafka, Spark, Fawna. So stay tuned.
Thank you, Jamie.